The purpose of this lab is to explore Newton's first law, which says that if forces acting on an object are balanced, it will either remain at rest or move at constant velocity. Part 1 explores the first part of what happens to the object. Part 2 explores the second part. When you click on the link, you will be taken to the simulation website. Click on the arrow and then choose Friction. You will see a display with a robot in a box. Follow the steps of the procedure and when ready, begin to have the robot push on the box. Initially, you can scroll forward using the slider under applied force. This will give you an opportunity to find a force that will just get the box to move, but you will want to use the double arrow button and then the single arrow button to find the correct value. Again, just get it to move and then stop. That is all that is wanted. You will find the force for a collection of masses stated in the write-up. When the data table is filled, time to move on. Without changing anything, check boxes or the slider you used for allowing some friction to be present. You are now going to see if the speed of the object affects kinetic friction. That is, the friction acting on the object once it is moving. Following the same procedure as Part 1, you now want to apply a force such that you have a low velocity that can be maintained for a short time period. You will likely find that this force is not as large as the force that is needed to get each object to move. Record the force for each object that maintains a constant low speed. You will then repeat this again for a higher speed. Though it is recommended that you use or learn to use Excel to do your graphing, you are welcome to do graphs by hand. There are step-by-step instructions to do this in the write-up, and you may be using those same steps for any future graphs that are to be done in the labs. Excel can be used to do the grunt work of graph creating with a few button clicks or checkbox entries. As an example, here is the data from the first part of the lab. It was simply copied from the write-up and pasted in the first two columns. The weight of the object should be in the first column, the applied force values in the second, to make sure weight is on the horizontal axis and applied force is on the vertical. Click your mouse on the label listed in column A and press the mouse button to choose labels and numbers of the two columns. Choose Insert and then choose the Scatter Plot Chart with no lines icon that just shows scattered dots. Your graph is now created. To prepare it for insertion in a Word document write-up, grab the corners to stretch it about 12 cells wide and 50 or so cells long. Once stretched, clicking on the plus symbol allows access to things like axis labels and trend lines. The exact steps are outlined in the videos on graphing with Excel that followed the lab write-up. What is to be included? You have 3 graphs to complete that should be put in the write-up after the questions, 1 graph per page and stretched to fill that page. If you did graphs by hand, you will want to take a picture of each graph to include in the write-up. A calculation of how you found the slope should appear in the calculations page following the graphs. If you did them using Excel, list the coefficients of friction values from the slope as directed in the write-up. Answered questions and completed lab tables are also included, all saved in a Word document, not a PDF, and uploaded to Blackboard.